Hello again, this is Andrea, and in this video we're going to be talking about perimeter and area of quadrilaterals and circles. So before we get into some of the worksheet problems, I'd like to go over a couple of resource pages that you guys have in the back of your workbook. This first one is talking about 1, 2, and 3-dimensional shapes. It is important that we understand the difference between the 3 dimensions, not only for our math problems, but also just kind of in our real life situations, that we deal with every day. And a lot of times our math problems bring in real world scenarios, and so it's kind of important that we have an idea of what we're really talking about. And mainly what we're really talking about is the meaning of some of the words that you'll see that would equate to either perimeter, area, or volume, and also just our units. What should our units be for these 3 dimensions? Okay, so let's start out with these 1-dimensional figures, and we can see that the example says a line or a perimeter of a shape, and indeed that's what we're really talking about is perimeter. When we talk about the 1-dimensional shapes, we're actually talking about the distance around a shape. A flat shape, basically, is what we should say. Distance around a flat shape. So some of the real world scenarios that we might have, like it shows up here, a line, right? Might be talking about a line. We could also be talking about maybe the trim. How much trim do we need in a room if we had some sort of word problem that had that in it? We might need to know how much fencing to surround an enclosed area, that sort of thing. We might be building a wall. We need to know how far does that wall go. And when we're talking about 1-dimensional shapes, our units are going to be, let me go back here. Our unit should be what we call linear units. And that just really means they are what they are. They're just in a line. So we have such and such feet, or so many centimeters, or so many kilometers, or miles. Okay, we don't square them. They're just simply linear units. Okay, moving on to 2-dimensional shapes, or two-dimensional figures. Here we're actually talking about the space inside these figures, and that's kind of important to know because we look at this word area, and that really means the same thing, right? Area means the space inside a flat shape. So let's actually write that out. Space inside a flat shape. And if we were trying to think of real world scenarios that we might encounter, we might have a word problem that asks us to figure out how much carpet will we need for a particular room. How much grass we might need to plant in a garden, something like that. You guys can think of, I'm sure, many, many more scenarios. But we're really talking about this space that exists inside or in an enclosed shape. And in our area units, our units are always squared. Okay, units squared, so we might have feet squared, centimeters squared, miles squared, so forth. And be careful, we don't square the number. We don't square the number. We square the units themselves. And the reason for that, let's say that our length here might be, now this is a square, but I'm going to just pretend it's not. Let's say this is 10 centimeters, and the width here is 8 centimeters, right? In order to find this area, we would actually have area is equal to length times width. So we would have area is equal to 8 centimeters times 10 centimeters. And if we wanted to go into a lot of detail about this, we would just show that this is the same as 8 times 10, And really, it means centimeter times centimeter. Well, we know from our exponent work that these have a little exponent of 1 on them, and we know because of the product rule we're going to add those exponents. So this is going to be 80 centimeters squared. We have 2 dimensions that we are multiplying together, therefore we're going to have the units squared. So of course you guys can extrapolate when we get down here to the 3-dimensional figures. We're talking about volume, okay? So in this case, we're actually talking about the space inside a 3-dimensional shape. Okay, so up here it's talking about boxes, cans, pyramids, cones, and those all have different formulas because their shape is a little bit different, but we're still just talking about the space inside that 3-dimensional shape. Okay, so we might be asked to figure out maybe how much, if we're talking about a box, maybe how much filling or packing, let's just use something like that, packing material. How much packing material would fit inside of a box? How much water to fill the swimming pool? Something like that. You know, we could go on and on and on with finding some cool examples of that. And of course, we know we've got 3 dimensions, and therefore our units are cubed. So we might have feet cubed, yards cubed, kilometers cubed, and so forth. And we can easily see this by just labeling these side lengths. If this is the length, this is the width, this is the height, you know, we can see, we know that we can always find the area by multiplying the length times the width. That's going to give us this measurement. And then if we include this height, basically we're saying, okay, if we filled that area on the bottom, on the base, and then just excuse me, multiplied it upward by the height, kind of like thinking of sheets. Well, how many sheets do we layer on top in order to fill this whole entire thing up, right? We can see that we have those 3 different dimensions in order to do that. All right, so that's kind of just a little synopsis of the different dimensions and the units that we are required to use for those. A second resource page that I wanted to point out to you guys, and that's also in the back of your book, back of your Math 90 workbook, is this 2-dimensional shape, or what we call plane geometry, because it exists on a 2-dimensional plane. And these are all the formulas that work for that. Now, these are concentrating, excuse me, a little more on the area. And I'm going to add some perimeter information to this. Basically, in terms of perimeter, I'm going to go over here and just add this at the side here. If we know that the perimeter is the distance around, of course, we could just add all sides. We can always do that. It doesn't matter what shape it is and whether it has a specific formula. We can always just add all sides, right? That would work. Oftentimes with a rectangle, I'm going to differ with this page a teeny bit here and call this length times width. The base and height work fine too, but I kind of like to just look at these a bit differently. We know in a square the sides are the same, so we might as well just call them both S's, right? The B and the H, base and the height, are really important in a parallelogram. It's important to leave those, but I would kind of differ with the rectangle and the square. Now, we do have specific perimeter formulas for the rectangle and the square, and you guys are going to see these quite often. If we know that we're adding all sides, so for the rectangle, we know that we're going to have 2 lengths plus 2 widths. So that is a formula that you guys are going to see, and I can just add the other length and the other width. You can see if I am adding all the sides, I'm going to add 2 lengths and 2 widths together, right? So that is one important formula. And in terms of the square, yeah, we can just add all sides, or we can say that the perimeter is going to be 4 s's, or 4 sides. All right, now let's look at the area measurements. So this says that for all 3 of these shapes here, that if we take the base times the height, then we are going to get the area. Okay, so we can kind of expand that a little bit since we're changing these the description or the labeling on the sides here. We can say in terms of the rectangle, I'm going to take some of these off here, that the area is equal to the length times width, right? And for our square here, if we're kind of getting rid of this knowledge of that the b is equal to h and just simply calling them sides, we can just say this is area is equal to side squared. Or if we think about that, that just means side times side. That's kind of like up here, length times width, but we're just calling them sides. So side times side is side squared. So for the parallelogram, like I said, it is really important for us to think about, to use the base and the height as labels. The reason for that is in order to have a true height, you have to have that line or that height perpendicular to your base. It has to hit at a right angle, and you can see inside the parallelogram they've done that for us. Out here you can see that this line is slanted, and in fact we call it a slant. Both of these sides are slant, so we can't use that as the height. We have to actually use that height that's drawn on the inside of this parallelogram. And in other classes you will figure out how to find that height yourself. For now, what we do is we're using diagrams that have that height written in for us. All right. Let's go down here to the triangle. Okay, so for the triangle, of course, if we were thinking about the perimeter here, right, the perimeter, we would just simply add all sides, as we said above. The area has actually 2 different options. We could say it's 1/2 the base times the height, or if you'd prefer, base times height divided by 2. And I always kind of base which version of this formula I use based on the given side lengths. If I have side lengths, a base or a height that's a fraction already, then I use this one. Maybe my base is 1/3 and my height is 3/4. Well, then I've got 3 fractions multiplied together, which is really easy for me to find the area. If I don't have any fractions in my given side lengths or base or height, then I'm going to just use this one, where I just plug those in. Like, let's say it's 4 and 8, so we have 4 times 8 divided by 2. It's a lot easier to use that one. So you guys get to choose which one you use based on the specific problem. Okay, let's jump over here to circles, because we are going to be talking about circles as well. All right, so here's our circle formulas. Now, if we talk, if we're kind of thinking in terms of the perimeter and the area, just to kind of start with, I'm going to jump down here. Basically, the perimeter of a square is what we call the circumference. So the perimeter is now called circumference, and that is the distance around that circle. And we can find that perimeter in 2 different ways. We can find it by C is equal to pi times D. We can see up here D is the diameter. I'm going to talk about that in a minute. Or C is equal to 2 pi times R, and R is the radius. We'll talk about that in a minute. So you guys get to choose which one of these formulas that you use, also based on the problem that's given. If it gives the diameter, use the first one. If it gives the radius instead, use the second one. Okay, and the area formula for a circle, of course, that means the inside. You know, we've talked about that before, inside a shape. So we're talking about this area inside here. And that is given by the formula pi r squared. So that's just pi times the radius squared. So let's go up and talk a teeny bit more about this idea of radius and diameter. Well, the radius is the distance from the center to a point on the circle. So go to the center and you can go to any point, right? Doesn't matter where. That would be our radius. That's basically half the distance. Right, this is half the distance across the circle. So then if we go down to the diameter, we can see that the diameter is the distance from one point on the circle through the center to another point on the other side. So here would be the center. You can see we'd have a radius here, and we would also have another radius here. And therefore, you can see why this formula is what it is. The diameter is equal to 2 radiuses, right? 2r. And if we wanted to extrapolate and go backwards, we could say that the radius then is equal to 1/2 d, 1/2 the diameter, or you could call it the diameter divided by 2. So we can see how all of these relate to each other. And the idea is use the formula that works very specifically for the problem that's given. Okay, guys, there's a few other things on here. You guys can see there's Pythagorean theorem, which we talked about a little bit earlier and in another video. There's a couple other things, and there's lots of resources at the back of your workbook too that you guys can use. All right, so I'm going to skip that other one. We're going to do a couple problems before looking at that other resource. So let's just kind of take a look here. Oh, actually, that's not true. That is not true. I want to talk about this first. Okay, I'm going to talk about this upper section, so I'm going to kind of try to truncate this a bit. All right, so it's kind of important for us to, in fact, really important for us to talk about the steps for finding unknown measurements in geometry. I want you guys to keep in mind that we are, yes, we're talking about geometry, right? We're talking about geometric shapes. And that is one thing that we're going to be tested on, is finding, you know, the unknown measurement. But that's just a small piece. Okay, this is one piece. But the other piece that's actually super duper important, and probably more important, is that you're actually being tested on our algebra skills. So we're using our algebra to set up equations. First of all, we're setting up equations which when we're talking about geometry shapes or geometric shapes, we call them formulas because they have more than one variable, right? So we're setting up these formulas, and we're going to then be able to stick in or plug in given points and solve for the missing side length. But this idea of using our algebra skills and showing our work is really where most of you guys' points are going to come from, because this is an algebra class, and that's what we're trying to do, is teach you how to use your algebra skills in various scenarios. And this particular one is geometry. Okay, so in terms of our steps here, we want to make sure we're reading that problem very, very carefully. And what we're really searching for is we want to identify what shape are we talking about, and what are you asked to solve for? Okay, that's actually really important. You know, reading the information and say, okay, here. So they're talking about a rectangle. So now I'm in my mind, I'm zoning down to, okay, I know I'm either going to find the perimeter of this rectangle or the area of this rectangle. Secondly, identify what you're being asked to solve for. Maybe it's very specific. Solve for the width, solve for the length, solve for the perimeter. Maybe it's asking you to solve for the cost of trim. Well, trim equals perimeter. So you have to sometimes use your knowledge of what the wording means and equate it to whichever formula is the correct one. And that is our second step here. And this is actually really, really important. We're going to write the correct formula down. Okay, we get that down on paper. Once we get that formula down, then we start plugging in the knowns. And what the knowns are just the given values in the problem. You know, in a lot of formulas, we have 3 or 4 variables. So we know that they're going to have to give us 3 of those, right? Because if we can plug in 3 of those into the formula, it leaves 1 variable to solve for. And that variable that you're solving for needs to be what we are asked to solve for, right? That's actually super important that we make sure that we're solving for what's being asked to solve for. And the only way to really do that is to make sure that we've substituted or plugged in all the other values. All right, so then next, of course, we're solving for the unknown, and we make sure that we're using the correct algebra steps and that we're showing all of our work. It's super easy and super tempting to do mental math with geometry. I am right there with you. I love to do that. It's kind of like a puzzle, and I just want to get in there and get it done, try to figure it out. Remember, though, you're being tested on your algebra skills, okay? You're going to check your solution when you're done by plugging all the values back into the formula. And then you write out your solution and make sure that you include those units. And be very careful. Remember, we're really looking for, are these linear units? Are we talking about perimeter here? Or are they squared units? Right? Unit squared means we're talking about area. That's perimeter, that's area. And of course, we're not really covering, not at all, I shouldn't say really, we're not covering volume, but if you were in another classwork, and then you would be cubing any volume units, right? This is actually super important. And remember that we're not cubing the numbers or squaring the numbers. We're actually just squaring the units themselves. Okay, guys, let's apply some of this information that we just learned. We're going to go and go to our worksheet now, and I'd like to try number 1A. You notice at the top it's asking us to show all of our work, write out our formula, all the stuff that we just talked about. All right, so we're going to read the directions. For each rectangle, so we now have identified the shape that they're talking about. For each rectangle, you are given the perimeter and either the length or the width. Okay, so we know now we're thinking about that formula for the perimeter of a rectangle. For the unknown measurement, find the unknown measurement using the appropriate formula. Check your solution by adding the length of the 4 sides, and then make sure that you use those measurements to calculate the area. So we are finding the perimeter and the area on these. Okay, so 1A says the length is 4 miles and the perimeter is 12 miles. So these are givens. These are what we know. These are some knowns, right? And we have another knowns. We know that we're talking about rectangles, and we know we are asked to solve for perimeter and for area. So first of all, our very first quest here is solving for perimeter. We're going to write down that formula. So perimeter of a rectangle is 2 lengths plus 2 widths. That is our formula, and we're going to try to get that down, right? Another thing too is, and I probably should have added this in the steps for geometry, super important. If you can draw a sketch, it's super important, and I think it's super helpful too. Draw a sketch if you can. Okay, so I'm going to do that. I'm just going to go over here, draw my rectangle, and we have 4 miles. Whoopsie, that's not a 4. So my length is equal to 4 miles. My width is equal to my unknown, right? That is my unknown right now. And the perimeter, so the distance around, I'm going to write that inside, is 12 miles. Okay. So if we think about our steps, we got that formula down, and now our job is to go back and plug in what we know. Okay, well, I know my perimeter, so I can take that out of there, call it a 12. And I know my length. Now I'm gonna do this here just because I want you guys to make sure you know that this 2 that we have here is in our original formula. We're not doing anything with that. That's not a given. That's just part of the formula. So we know our perimeter is 12, our length is 4, and we're still solving for the width. And you notice we had this original formula that had 3 variables in it. We had the P, the L, and the W. Well, there's no way that we can solve an equation if we have more than one unknown in there, right? The rule of algebra is for every unknown or variable that you have in an equation, you have to have that many equations to solve it. So later on in Math 98, for those of you who are going on to Math 98, we will get into systems of equations. Well, we're actually going to be having 2 equations and 2 unknowns. But you can have as many equations. In fact, in a lot of science careers, they do a lot of work where they have hundreds of variables, and they're big. They have big computers that help to solve the value for every single one of those, and you have to have that many equations, of course, to solve. Okay, enough about that. Let's get back to the problem at hand. All right, so let's just do some math here. We've got 12 is equal to 8 plus 2w minus 8 minus 8. I'm going to go over here. All right, so we've got 4 is equal to 2w, and we just easily solve this, and we can turn this around. W is equal to 2. Okay, so what does this mean? What does W is equal to 2 mean? Well, we know W is equal to width, so we know that our width is equal to 2, and I have to include my unit, so 2 miles. And we know those are linear units, so we're just going to leave it at that. Okay. Now, we know, secondly, we need to solve for area. We know that the area of a rectangle, we're going to write this. I'm going to go ahead and get rid of this so it's not in the way here. We know that our formula for the area of a rectangle is length times width. And we have, okay, cool. So we now have to extrapolate on here. Let's plug in what we know. So area, we know we're solving for area here, right? We know the length is 4. And now we know that the width is 2. We have that, don't we? So we're going to go back to red. Here is equal to 8. And we have to be careful here. I oftentimes don't use my units in the actual math problem. I find that they get in the way, so I don't really like to use that. But if we're thinking about this, we're really saying the area is equal to 4 miles times 2 miles. And we know miles times miles is going to give us 8 miles squared. So this is going to give us 8 miles squared. Remember that we don't square the 8, we square the units. All right, guys, so that's our first example. I'm going to jump down here to numbers 2 and 3. You notice that these aren't shapes that we are real familiar with. They're not quadrilaterals, right? We don't have these kind of 4-sided shapes that we're working with where we have a specific formula. But we do know that in order to find the perimeter of any shape, we can just add all sides. And in number 2, you can see you don't even have an unknown. You just have side lengths. So you can just simply say perimeter is 34 plus 22 plus 20 plus 22 plus 27. And you're going to write that out, right? You're going to want to write it out because we want to make sure that we're showing all of that. I'd like to take a closer look at number 3. You notice we do have an unknown here, and we're going to be using our algebra skills. So anytime we have an unknown, we're going to want to just give it a variable. We're going to define it as an x or a y or whatever variable you'd like to use. It says, given the perimeter of 96 feet, what is the length of the missing side? The missing side is going to be our x. And like I said, we're going to want to make sure that we write out some sort of a formula. Okay, and this is an interesting shape. It's got all kinds of weird cuts, right? So we don't have a specific formula. So even though it's a pain in the butt, we are going to say that perimeter, of course, perimeter is adding all sides Specifically, perimeter we know is, let's just go to black here, 196 is equal to x plus, I'm just going to go to the right here and just add them all up, 32 plus 20 plus 10. 10 is actually this side right here, plus 16 plus 18 plus 12 plus 40. Okay, and you guys can actually just figure this part out on your calculator. You don't have to sit there and go one step at a time on that. That's kind of a waste of time. 196 is equal to x plus 148. And we're just solving this using our fabulous algebra skills. Okay, so I'm going to have to go over here. Oops, I'm out of room. 196 minus 148 is going to give me 48, so x is equal to 48. And I'm asked to solve for the side length. This is a geometry problem, so I want to make sure that I include my units in here. So these are linear units, so x is equal to 48 feet. All right, let's move on. Let's actually take a look at problem number 4. So in problem number 4, we're also asked to find the perimeter or the circumference, if we're talking about the circles, and the area of the following shapes. I'd like to look at 4C first, just because we have fractions. Sometimes that can be a little bit problematic for students, and so I just want to take the fear out of it for you. All right, so remember our steps. Okay, when we're first of all, we're trying to find the perimeter. So we're just going to write down our formula. So perimeter is equal to 2 lengths plus 2 widths. Usually our length measurement is the longer one. Our width measurement is the shorter one, right? And we have 3 variables in here. Of course, we know we need to plug for this length and this width. Otherwise, we can't solve for it. We also notice up here that we have mixed numbers. And mixed numbers, if we're going to do this in terms of fractions, we have to make them impropers, don't we? So this is going to become 11 halves and 28/29 fourths. All right, so once we do that, we can come down here and stick those improper fractions in here. All right, let's go back to the black. So we've got perimeter is equal to, now I'm going to just say 2 over 1 times 11 over 2 plus 2 over 1 times 29 over 4. Now, I would highly recommend in this situation when you've got some bigger numbers that you do some cross-canceling. Here we have the 2's that would cancel out, which is nice. This leaves 11, so perimeter is equal to 11. Okay, plus we've got the 2 that would cancel out with the 4, leaving a 2 down below, so 29 halves. And since we still have fractions, I've got to put that back over 1. Okay, this is a lot easier though to deal with just a common denominator of a 2. So we're just going to multiply top and bottom by 2. So perimeter is going to be 22 plus 29 halves, which is going to be 51 halves. So perimeter is 51 halves. Now, we don't talk like that. We don't say, well, the perimeter of the garden is 51 halves inches, right? That doesn't work. So we want to make sure that we convert that back to a mixed number. We can also use decimals here. So you guys could say 25 and 1/2 inches. Or if you wanted to just put that on your calculator, you would get 25.5 inches. That's okay. Either one is perfectly fine. So that's our perimeter. Okay. And we know that our area, go back to writing down our formula. The area formula for a rectangle is length times width. Okay, so we know, once again, we're going to plug our values in. We're going to go to those impropers again. 11 halves times 29 fourths. And unfortunately, there's nothing that we can do in terms of canceling on this. So we're going to have to do the math. 11 times 29 is going to give us 319 over 8. We would never leave it like that. That just doesn't make sense, does it? So we would use our calculator, 39.9 inches squared, because we're talking about area measurements. Now, I want to say right up front that since you guys' fractions here are, they terminate, 1/2 and 1/4 terminate, that you guys could have done this entire problem with using decimals. So if you had wanted to, you could have just called this 5.5, and of course this width would have been 7.25. And if you had wanted, you could have just plugged those right into that formula. I'm going to just write it right up here. You would have had P is equal to 2 times 5.5 plus 2 times 7.25. And that would have gotten you your answer a lot quicker. But, at the same time, it's good to practice your fraction work as well. But I'm going to leave it up to you, whatever you guys want to do. If you guys want to kind of start working with decimals too, that's totally fine with me. All right, guys, I guess the one thing I will say, be really careful. If these fractions had a denominator, like here, of a 3 or an 8 or a 7, where you had to do some rounding, make sure if you're using decimals that you would have taken it out at least three digits. For example, I'm going to just make something up here. What if it was 5.52987? You would have wanted to at least say, so 529, maybe saying 53 or 5229, and then bring it out one more digit or something. So take it out a couple of place values if you have to round. Otherwise, your answer is not going to be the same as what's in the back of the book, and then you're not gonna feel like you got it right. Okay, guys. Let's see here. What else do I want to do? Let's take a look at E. Here we have a circle, so we kind of want to talk about that. We know we're supposed to find the perimeter and the area of the circle. Okay, so we know that the perimeter of the circle, a perimeter for a circle is equal to circumference. Okay, so we're going to actually have to use the circumference formulas, and you notice here we've got this label here, or this on our, on our circle, we've got a radius here, don't we? Because it's half the distance from across the circle, so it's from the center to the side. So on our circumference, we want to use the formula that has the r in it rather than the d in it. And we can easily do that. We can go to our formula sheet, and we would have found that circumference is going to equal 2 pi times r. I want to make a note here, guys. Do not use any longer 3.14 for pi unless it tells you. So maybe on NROC it'll ask you to put in 3.14. If it asks you to do that, then go ahead and do that. If not, what I want you to do is use the pi button on your calculators. Okay? Find the pi button and use that on your calculator. Okay, because the pi button is exact. Remember that pi is an irrational number. Those numbers never terminate. And so if we put in 3.14, we are actually rounding. We're getting an approximation rather than an exact number. And in fact, in our final answer, if we don't have pi left in our final answer, it is also an approximation, because we have to truncate pi to write down a specific number. But that's okay. That's okay in this class. We're actually going to just accept rounding to the nearest tenth, at least for these problems here. Okay, so here's our formula, and we are going to then go and plug in what we know. We know that the radius is 12, right? So we're going to have circumference is equal to 2 pi times 12. We could also even simplify this a little bit more by just taking 2 times 12, and we could say 24 pi. Now in a lot of classes, we would have just left it like this. 24 pi is an exact answer, okay? But in this class, we're going to just take our calculators and say, what is 24 times pi? And we would have had an answer. We'd want to make sure that we round to the 10th, 75.4. Okay, and it usually will tell you what to round to. I noticed in this worksheet we don't actually specifically ask you guys to round. You would generally round, if it doesn't say what to round to, you would generally round to the 10th or maybe to the 100th. So just kind of keep that in mind. Just double checking my answer here. Okay, sorry guys, 1 second here. My calculator's being silly on me. Oh, there we go. Okay, yeah, because the original answer there was 75.398222369. So we're going to want to head and just go ahead and just round to 75.4, and we want to make sure that we put in our units. Remember that circumference means distance around, so that's just a linear measure, so we're just going to leave it as inches. All right, area. So we go to our formula sheet. Area of a circle is pi r squared. Okay, and that's actually convenient because we have r. R is equal to 12. So we're going to take our 12 and then we're going to square that. Now, if you're, just get this down. I'm going to make a comment here. If you were doing this problem, and you were having to say, okay, area is equal to pi r squared, right? And we have d here, right? We've got d is 6.6. We would want it so that we can plug in the r. We would make sure to have this 6.6 because we know that the radius here is half of the diameter. So you just sometimes have to do a little bit of side work to get the the exact measurement that you need. Okay, so 12 squared is 144. So area is equal to 144 pi, and that would be inches squared. That would be our exact answer, but we'll go ahead and and multiply those together. And when we do, let me get the actual. So 144. Yeah, it definitely is a long, non-terminating number, 452.389341, and we want to just go ahead and approximate that to the 10th, so we'll say 0.4, and of course inches squared, because this is an area measurement. All right, guys. One little comment here on this, on G. This is not a recognizable shape. It's like a backward L. We don't have a formula for a backwards L, right? But you guys can use, just kind of use your other strategies. Look at it and then break that down into pieces. You know, I think a good possibility would be just to divide this here. You've got what you need, right? You just have to kind of use your brains a little and kind of, look at what you have. You could have also broken it this direction. So just going to throw that out there for that, just give you some ideas. Okay, let's talk about parallelograms here. All right, so here we have parallelogram. We don't have a drawing of that. Like I said in a little bit earlier, it's always a good idea to go ahead and, if you can, just draw yourself a diagram or a little sketch if you can. Remember that a parallelogram is kind of just like it's like a rectangle that we just kind of pressed down the sides and squished a little bit. That's a really awful drawing. I apologize for, oopsie, for my lack of artwork or art ability. Oh my goodness. All right, that's awful. There we go. That'll have to do. All right. We know that the base is going to be down here, right? We also know that the height is something we have to draw in and have, it has to hit that base at a right angle, right? So our height would actually be in here. All right, let's go through the problem. The area of the parallelogram is 500 centimeters square. The base is 25 centimeters. And our job is to find the height, okay? So we know the height is going to be our unknown. So we're going to leave the h as is. That's going to be our unknown. And 25 centimeters is our base, okay? And of course we know that the area is 500 centimeters squared. Okay, so we get an idea of what formula we need just because we're looking at the information in the problem itself. We know that the formula for the area of a parallelogram is base times height. Okay, we've got three variables here. We know we can only have one in order to solve for what we need. So we have to start plugging in some given information. Okay, area is 500. Base is 25 times our h, right? And we don't necessarily need that little raised dot in there. Okay, then we just start solving this, right? We know that we can just easily get rid of that 25 by dividing that coefficient out of there. And I can turn this around, that the height is equal to 500 divided by 25, which is going to give me 20. Okay, and my units there would be centimeters. Now, even though we're talking about area, only the final area is squared. We already know that, right? And that's because our base and our height both are in centimeters, and centimeter times centimeter is going to give us that centimeters squared. Okay, so we just leave that in our as our linear measures. Alrighty, guys. A couple more things. I know this is kind of a long video, but a couple things, other things I wanted to point out to you guys. Number 12. Just kind of give you an assortment of some examples here. So here we have a triangle. Okay, and you notice in this problem it says the perimeter of the triangle is 56 meters. Okay, and they want us to find the area. So there's some stuff going on here. Okay, the perimeter is 56, find the area. All right, well, if we think about this, let's go ahead and write this down. So area of a triangle. Let's look at our labels in terms of our numbers. We don't have fractions, so I'm going to use area is equal to base times height divided by 2 rather than using the fraction formula. And of course, the perimeter of a triangle is just simply adding all sides. Right? We know that those are our two formulas that we're going to be using. Now, if in the end I'm supposed to find the area, I need the base and the height. Then right now my base, here's my base, right? Here's my height. Both of those include x's in them. So there's no way that I can solve for the area until I solve for the perimeter, right? Okay, so let's start there. If we know that our perimeter is adding all sides, then I know that I'm going to put my perimeter. I already have my perimeter measurement here, right? So I'm gonna rewrite this though because it just feels more algebraic. Add all sides. All right, perimeter is 56, and that is going to equal 3x. I'm going to use some parentheses, even though I don't need to, but I'm just kind of trying to show the different sides that I have, that I've actually included all three of them. So here's the three sides of the triangle. Now I can, since I'm adding everything together, I can drop those parentheses and start combining my like terms. So I've got 3x plus 3x plus x. That's going to give me 10x. Or no, it's not. It's going to give me 7x's. What am I doing? 7x. And then I've got a plus 1, minus 1. So that's convenient. I can get rid of those. And it looks like x is equal to 8, doesn't it? Okay. So that's helpful. Now, what would we do next? All right, we still need to figure out this area, so I need to know what my base and my height is, and I can't have x's in there. Well, we just solved for x. We know that x here is 8 and 8 and 8, don't we? So if we just plug in an 8, we've got 3 times 8. So we know that 24 is our height. And here's 8 minus 1, so it means our base is actually 7. And here we would have 24 plus 1, so 25 is actually equal to the, this is actually the hypotenuse, isn't it? This is a right triangle, so that's the third side here, is 25. Now we can go ahead and fill in some info here. So let's rewrite this. Area is equal to base times height divided by 2. All right, base and height are going to be filled in by 7 times 24, right, divided by 2. And if you guys want to make your lives easier, you can go to your calculator and say 7 times 24. You're going to get a very big number. You can also, since all this is multiplied together, just do some canceling. 2 actually goes into 24 12 times, and 7 times 12 is 84. So it makes it easier to do some mental math there. So area is equal to 84. Got to make sure that we're squaring those units, but we don't have, oh yeah, we do, inches. So inches squared. And of course, you guys can check that, right? You can go back and plug in and check that. And in fact, you can check that. You could even check that using your Pythagorean theorem if you wanted to check it in a completely different way. Okay? All right. Now, I want to discuss number 14. I don't want to actually work number 14 because we don't really have time, but number 14 is an interesting shape. Looks like a pencil, actually. This says, Mrs. Glaze wants to make awards for her students in the shape of pencils using the design below. What is the area of the award to the nearest tenth of a square inch? So we don't have a formula for the area of a pencil, right? That's kind of ludicrous. So we need to kind of think about what we would do to find the area of this. Now, I'm sure you guys have already figured out, and maybe have already done this, but we're just going to break this down into different shapes. All right, this is a recognizable shape. Of course, we have a rectangle here, don't we? So we know this shape. And of course, we also have this sideways triangle here. So we have 3 different recognizable shapes that we can use in our final work here. Now, I think this one might be the trickiest here, but we know that this is just going to be a semicircle, right? This is literally just a half of a circle, or a semicircle, right? So if we were thinking about the area of a circle, right? The area of a circle is pi r squared, right? Pi times r squared. Well, we would just divide that by 2. You can multiply by a half if you want, or just divide by 2. That's going to give you your semicircle, right? We know the area of a rectangle is just length times width, so you can figure that out. And actually be careful here. I'm just going to put a little warning here. Oh, actually, no, we're okay with that. Yeah, we're okay there. Sorry. Okay, what am I doing? Go back to that. Here, we just have our triangle, right? And we have a height drawn inside there. You can see that because here is your right angle symbol. And we don't have a fraction in our label, so we're just going to do our base times height divided by 2. And if we add all those together, we're going to get the area of that cute little pencil. Okay, guys, so that was just some ideas for a couple of those. Lastly, the last part of this video is all about similar shapes. And you guys do have some questions here. Actually, I apologize for going back and forth so much. But these questions here in 13, the following shapes are similar, right? These are similar. Find the missing side length. Well, we need to talk a little bit about similar shapes and how we deal with them. And then you guys can apply that information to those problems. So let's go to this toolkit here. So what are similar shapes? Similar shapes have, of course, the same shape, the same angle measures, but the side lengths are proportional. This is actually huge. The side lengths are proportional. Okay, it means that there's a ratio that we either multiply or divide by from one to the other. Okay, if we look at our diagram here, we have two similar rectangles. Okay, so basically it's the same shape. All of these rectangles have right angles. And you notice that we just have this one missing side length here, right? But it's showing that we have let me start over here. Because of the fact that we know that our side lengths are proportional, we can look at this side length here at the bottom, and we know this is 7 and this is 14. We know that what we did is just multiplied by 2. Right? That's our ratio. That is our common ratio from side length to side length. Therefore, we can actually go from this side length, which is our width, right? Our width is these were our length measures, and A is going to be our width. And so we would just simply multiply by 2 here, and we would say, oh, okay, well that means that A is equal to 6 centimeters. And we know that that would be proportional. Now, that was using mental math. Right? That was using mental math. So unfortunately, we cannot use mental math in this algebra class. Mental math is always a great way to check your work or to predict what you think you should have, but of course, that's not going to get you the points that you need in terms of the algebra of it. So we need to talk a little bit about how do we then show this? How do we go through these steps? So the idea here is we want to use proportions. Okay, we want to use our what we learned in our proportions unit. And what we're really going to do is we're going to set up two ratios with corresponding side lengths. Now, I want you guys to know that you have some options here. We could set up corresponding sides of different figures, or we could set up corresponding side lengths of the same figure, as long as we are very, very careful to place the X in the correct position, then we're okay. Let me show you what I mean by that. I'm going to call this, just for kind of maybe an ease of talking about this, I'm going to just call this figure A and this figure B. All right. So one option, if we were thinking of setting up the ratios in terms of different shapes, then we would have to just set up kind of correlating side lengths. For example, we would set up our lengths over each other. So I could set up A over B. I could say, all right, this is 7 over 14 is equal to, remember I'm setting up a proportion. Remember a proportion is A over B is equal to C over D. Right? Now, I would go to the length. to the width. Here's my width and my width. Since I started with A here on the top, I have to start with A on the top then in my second ratio over A. So I have to make sure my A is from my figure B, right? Since both of these bottom numbers are for figure B. So these are kind of setting up different figures in as a proportion. Now I could have flipped that. I could have put 14 over 7 is equal to A over 3, as long as I know that my my numerators, for example, here's my numerators. You notice here, this is from figure A, and my denominators are from figure B. Okay, the other option that I could have done is same figures. Right? So if I wanted to, I could have gone back and said, okay, I'm just going to deal with A first. I'm going to put 3 over 7, let me say or here, 3 over 7 is equal to A over 14. I could do that if I want. And you notice here that the numerators are both my widths, right? And the denominators are both my lengths. But my ratios, instead of going from one figure to the other in a single ratio, I've actually got my ratio of 3 over 7 is all for A, figure A, and then A over 14 is for figure B. You guys have so many choices here, because I could have flipped 7 over 3, 14 over A. You guys have tons of choices. What I want you guys to just be careful of is just be consistent. Okay, so this whole idea here is just be consistent. Make sure that what you do in one ratio in terms of your order is what you do with your second ratio. And either way, you're going to be just fine. Okay, secondly, you're going to use cross products to solve for the unknown side. Remember, with cross products, right, if we have A over B is equal to C over D, we're using cross products and we're setting up equations. So that's going to be A times D is equal to C times B. And then we solve for whatever our unknown is. Okay, so if we go up here, I'm just going to pull one of these down. It doesn't really matter. Well, actually, I think I'll leave them because then I can show that both ways it didn't really matter. Okay, let's do that here. Let's do our curve. Oh, no, I forgot. I didn't have my eraser. Crud. It's okay, no problem. Sorry guys, I'm going to go back here and rewrite this. So we had 7 over 14, that was our length, is equal to 3 over A. Okay, let's use cross products here. We're going to go multiply across. So we have 7A is equal to 14 times 3. Okay, 14 times 3 is 30, 42. So 7A is equal to 42, divide by 7, and A is equal to 6. And you know what? That's what we expected, isn't it? When we did that mental math, that's what we expected to have happen. You guys can see over here, let's just, for grins, take a peek at that. These numbers are in different positions, but it doesn't matter because we get the same exact equation and we're going to get the same exact solution. As long as you have your unknown in the correct corresponding place and that you're consistent in terms of what you're putting in your ratios, you guys are going to get the exact same answer either way. Thirdly, let's go back down here. So we used cross products, set up our equation. We want to check by plugging the solution back into the proportions. And I would kind of just highlight here, check using a different method. I feel like if you check using cross products, you're just undoing what you just did. And it's kind of like you just did that. So I kind of like the method of checking using a complete different method. For example, we can check up here by plugging in our 6 here. Well, if we were to, in this example, if we were to check, we could see that this is going to give us 1/2, because 7 is half of 14, is equal to a half. So what we're doing here is just using the idea of reducing fractions down. And we checked that, okay, yeah, that's correct. Now, of course, this is a simple example, but a lot of times you don't have simple examples, so it's good to check. Over here, 3/7, we can't reduce that down, so we might want to use a completely different method to check. I'm going to bring this one down here for a moment. Let's bring down 3/7 is equal to 6/14. Now these are not, common fractions. So one thing that I like to do is use your calculator here and come up with your decimals from each. Make sure you remember that this just means division, right? These fraction bars here just mean division. So we're going to take 3 divided by 7. And I get 0.42857. 2857. Now this goes on and on and on, but I won't write all of that out. And then I'm just going to take 6 divided by 14, and I get exactly the same answer. Okay, so that's a check as well, and it's just in a different way than how you solved that problem. I want to point out that you guys need to be very careful when you're rounding. Let's say when you did your original math that you got some decimal. Let's just say, you got whatever. Let's just say you got 2.257, something like that. And you decided, or you were asked to round. So you would have rounded that to 0.26. Well, if you do your check with the rounded number, it's not going to come out the same on both sides. So just be cognizant of that. When you do your check, put in your original so that your check is actually accurate. Okay? And of course, we include our units in our final answer. Okay? So something that I didn't do yet. So A is equal to 6 centimeters. 6 centimeters. Okay, guys, so you've got a few problems on your worksheet to try with the similar shapes. All right, that's it for now, guys. We'll talk to you later.